All right, today is a review of vectors, things that you learned last year in pre-cal. Some of you will remember, some I don't expect you to remember everything, and that's okay. We will just go back over it so that you do remember and you're ready for the last two lessons. So, let's take a look here. It says in geometry and physics, concepts such as temperature, mass, length, area, and volume can be quantified by a single real number. These are called scalar quantities. Scalar means a number, just a number. It has something to do with a vector, but it's a number, okay? A scalar quantity, the number associated with it is called a scalar. But force needs more than just one number to describe it. It needs an amount and then sometimes an angle. It needs more things. It has size and it has direction, and it cannot be characterized with a single number. So what we use that for is vectors. So we have two parts of a vector, the head and the tail. The initial point is the head, the terminal point is the tail. Remember, you always say where the dot is first, just like you do with a ray in geometry. Okay? So these things are denoted with magnitude, which is its length, by the double absolute values. Do you remember that? Double absolute value bars means magnitude, how long it is. Okay? And then we call each one of these a vector in the plane. When you get into college, you will learn about three-dimensional vectors that go up into space. So they will have three components to their direction and three-dimensional graphing. Usually lowercase bold-faced letters, U, V, and W, are the common letters used for vectors. Okay, we're going to jump down to the next part down here. We're going to talk next about what is called component form. Component form is when you have a vector in bird beaks, basically. The less than, greater than. Okay, so if I gave you the component form 3, 4, you know what that means? That means that that's where the tail is. The head is at 0, 0. Component form means it starts at 0, 0 and goes to that point. So this is the same as 1, 2, 3, 1, 2, 3, 4. Put your tail up there, and the head is at 0, 0. That's what component form means. It tells you where it ends. Because usually a vector, you would need 2 points. The coordinates where the head is, the coordinates where the tail is. I may be saying these backwards. The tail is the dot. Have I been saying it backwards this whole time?
Yeah. I believe so.
Ah, you believe so. Let me get this straight. The head is the top of the vector, and the tail is the dot. This is where the arrow is. Let's get it back to simple English, okay? This is where the arrow is. And the dot, the initial point, is at 0, 0. That's the important thing. Okay? So what we're going to be talking about first is how to take two ordered pairs that describe a vector someplace else and move them down to the origin. Okay? Move them down to where the initial point is at 0, 0. So it tells you that if one point of a vector is P1, P2, this is the initial point, and the Q is the Q1, Q2 is the terminal point, then the component form is written by subtracting Q minus P1 and then subtracting Q minus P2. So it's the arrow minus the dot in simple terms, the arrow minus the dot. And then the length of PQ is the square root of the component subtracted squared plus the component subtracted squared. Okay? This means we do not need both an initial point and a terminal point to represent a vector. So what we're going to do is we're going to look at 2A. Let me move this up. Given an initial point and a terminal point, write each vector as a vector in component form and find its magnitude. So this is my starting point, this is my ending point. These are the P's, these are the Q's. So component form would be the left side, and then it would always be Q minus P. It has to be in that order. So it'd be 6 minus 3, comma, 12 minus 8. Now if you can do that in your head, you don't have to write this step. You could just go straight to 3, comma 4, which is what I wrote down a minute ago. Okay? So that's the component form of that vector. Now to find its magnitude, we're going to call this vector V. To find the magnitude of vector v, we take the square root of our new vector and square each its x and its y. So it's just 3 squared plus 4 squared. And what does that equal? 16 plus 9 is 25. Square root of 25 is 5. Now remember that magnitude means how long it is. How long is my arrow? It's 5 units long. The arrow that I drew up here is 5 units long. Okay? Questions? Nope? Easy stuff? You do B. Okay. Are you mentally picturing what's happening here? Do I need to draw a picture? Would it help? Yes? Okay. So let's take this one right here, and I'm not going to do letter C, so I'm going to mark that out so I know that it's free area. 4, -6. Where is 4, -6? What quadrant? Fourth. And then -1, 2 is in the second, so I'm kind of covering the whole graph. Okay, so I'm going 4, -6 is my initial point right there. Okay, and -1, 2 is my terminal point. That's where the arrow is. So I have a vector right here. This is letter B. That's the vector I'm starting with. 4, -6, -1, 2. It's right there. Okay? Now, I want to shift it so that the initial point is on the origin. So it is going to continue to point in the direction that it's pointing. So it means my answer will be in what quadrant? For where the arrow is going to stop now. Still going to be quadrant 2. Do you agree with me? So if I take this and move it, okay, I know that the initial point is going to be at 0, 0 because that's where it always is. And I know that the terminal point is going to be up this way, somewhere up here. It's got to be the same length, same angle, everything. So the way that you could do it on a graph is you could just count how many steps up and then how many steps over to get to there. So it's 6, 8 up, and then 5 over. So I would go 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5. There's my head of my arrow now that I've shifted it. And that would be at -5, 8. Didn't I say I went 8 up and 5 left? So that's the point, -5, 8. That's what I got for the component right here. That's what that is. Okay? And then to find out the magnitude, I'm just using Pythagorean theorem. It's 5 squared and 8 squared because I'm finding the length of the diagonal. And that's the square root of 89. Okay, so are we seeing a picture now of what's going on? Yeah. Okay, I think it helps to really do that because it makes the math make sense. Any questions? Okay, turn to the next page, please. So at the top of the next page, they talk a lot about adding vectors and what the different notation means. Okay, so if they're just not on a grid, just out there. You know, you've dealt with angles just kind of on a piece of paper with no lines or no location. They've also had angles that are on the unit, on the coordinate plane. These are just out there vectors. So if you have a vector v, 2v means it's twice as long. -2v means what else? What does the negative mean it does? It goes in the opposite direction, so the head and the tail switch. Okay? So, to add two vectors, you draw them head to tail. So if you have a vector u and a vector v just kind of sitting there, you slide vector v over so that its tail hits the head of vector u. Okay? And then you connect the starting point of u to the ending point of v. That's your addition u plus v. We're not going to be really doing this on paper, but we're talking about how it works. Okay? And so subtracting, what you have to do is you have to take the second one and flip it over, and then you do the same procedure. But here is some information that you need to know at the bottom. First of all, if you have a scalar, a number that you multiply to a vector, you just multiply that number to both terms inside. You just basically distribute it, okay? If you add two vectors, you add up their x's and then add up their y's. A negative of a vector just changes the signs. Subtracting two vectors, you just subtract their x's and y's. And now here's the one that doesn't necessarily strike you as quite as obvious. If you have to multiply a constant to a vector and then find out how long it is, you can either do it as it's all one unit, or you can separate them. It may be easier that way. And we're going to show a problem where it is actually easier to keep it separated in just a minute. Okay, so let's go to the bottom, number 3. Let's do some math. We have a vector u, and remember this means that its tail is at 0, 0, and its head is at negative 3, 7. This one is at 0, 0, and the head is at 5, 1. What is negative 1/2 times u? What is it going to look like in component form? What do you think?
No. Three. Yeah,
Positive 3 over 2. Half of 3, or 1 point. You could say 1.5. That would work.
Yeah.
And then what's the other one going to be? Negative 7/2. I'm done. That's all you got to do. You just multiply the negative 1/2 to both components. Okay? Now what does the notation for b mean? Magnitude. So I want to know how long that vector is. How long is this vector? So I'm going to say that the magnitude is the square root of the 3/2 squared plus the negative 7/2 squared. Yuck. Okay? Or by the rule that was on the very bottom right here, I could do it this way, or I could have taken it back to where it was before I multiplied in the half and then just do half the length. Watch this. I'm going to take this and break it apart. So I'm going to have the absolute value of negative 1/2 times the length of the original vector u. So that would be easy. That's easier to do, isn't it? That's negative 3 squared plus 7 squared. Do you see what I'm doing? I'm pulling the 1/2 out. It's just a lot easier to do it that way. So both of these methods are valid. So let's just do it the top way. What's 3 squared?
9.
7 squared.
49.
Add them together.
58.
Does it come out even? Square root of 58, does it break down at all?
Yes.
2 times 29,
Yeah, no, it doesn't.
No. and 29 is not, 2 and 29 are both prime. Okay, so what we're going to do is we're going to say this is the square root of 58 times the absolute value of negative 1/2. So that means that the answer is the square root of 58 over positive 2, and that's my length. That's the way we're going to leave it. I want you to do C and D, because they go together, and G and second G. I didn't catch that until today. Make that H, G and H. So do these 4 over here right now. C, D, G, and second G. Okay, so adding U and V. It tells you up here, you just add the first thing in every parenthesis, then add the second thing in every parenthesis. So negative 3 plus 5 is 2. 7 plus 1 is 8. Is that what you got? Yes? And then this means find the length of that. So we do the square root of 2 squared plus 8 squared, which is the square root of 68. You can just leave it like that. Now I know that breaks down, but you can leave it that way anyway. So here, 3 times U would be negative 9 and 21 minus 4 times V would be 20 and 4. So that's going to be negative 29 and 17. Y'all agree?
Yes.
Can y'all see? So you multiply the U1 by 3, so it's negative 9 and 21, minus you multiply the 4 1 by V, you get 20 and 4. So negative 9 minus 20 is negative 29. 21 minus 4 is 17. Now some of you may have multiplied the V1 by negative 4, and that's okay, but you got to add them together after that. Don't do a double negative. And now we do the magnitude of my answer. So it's negative 29 squared plus 17 squared, which comes out to be the square root of 1130. Did y'all get that?
Yes.
Awesome. Any questions on this? Okay, do you remember doing this?
Yes.
Yes? Okay, good. All right, the next thing is what's called a unit vector. And that is a vector that is 1 unit long. 1 unit long, tiny little vector, okay? It is in the same direction as the original, but it has a magnitude of 1. So the way you find it is you find the vector itself and you divide it by its magnitude. Okay, so using the vectors in number 3, find unit vectors for the following. And it says to show they have magnitude of 1. I didn't do that in first period. So vector u was negative 3, 7. So the first thing I do is find its magnitude, which I already did. Look back up at number 3b. Now this was the vector, this was the magnitude of half of it. So what would the magnitude of the whole vector u be?
Square root of 58.
Just the square root of 58 without the 2 on the bottom. Okay? So the magnitude is the square root of 58. So my unit vector, which I write like this, u over the magnitude of u equals. I draw a little bit bigger bird beaks because there are going to be fractions in here now. It's just negative 3 over the square root of 58, comma, 7 over the square root of 58. Close it. Now, if I squared this, let's go ahead and do this real quick. So if I squared this and added to it the other one squared, whoops, I forgot the square root on the bottom. What happens? Well, what is negative 3 squared? 9. So the square root of 9 over the square root of 58 squared is 58. Plus 7 squared is 49. And the square root of 58 squared is 58. And when you add those together, you get square root of 58 over 58, which is 1. So that tells me that what I just created is 1 unit long. I just found its magnitude. Okay? Now, are they going to make you do that every time? No. But think about it. If you have something that is 5 feet long, and you want a piece that is 1 foot long, 1 foot long, how many pieces do you chop it into? 5. You divide it by how long it is. That's how long it is. So you divide it by how long it is to make it 1 unit long. Okay? All right, u plus v, what did we get? That was 2, 8. And we found that its magnitude was the square root of 68. So we write u plus v over the magnitude of u plus v equals big bird beak. What is my first component? 2 over the square root of 68, comma, 8 over the square root of 68. And I'm done. I'm not going to prove that it's 1. It's just going to work. That's how you find unit vectors. Divide by the magnitude. Okay? Questions? All right, go ahead and turn the page. Okay, the top of the next page starts talking about the standard unit vectors. The unit vectors 1, 0 and 0, 1 are called the standard unit vectors and are denoted by the lowercase I and the lowercase j. The lowercase I is a vector that goes to the right from 0, 0. The vector j goes up 1 unit from 0, 0. So these vectors can be used to represent any vector v1, v2 by writing it v1i plus v2j. This is called the linear combination form of I and j. So anytime the directions say write as a linear combination, they want you to write the vector with i's and j's. Now it may you think, well, why? We already got a good way to write it. This method is great for solving word problems. Okay, so that's why we do this. So we're taking the component form and breaking it into what's called linear combination form. So we have u, the vector with an initial point here and a terminal point here. So this is our p and this is our q. This is not in standard position. So v is already in linear combination form. So we're going to write the following as linear combination. So we're going to take u, which is the p, q together, put it into bird beak or the component form, and then we're going to write it in ij form. Okay? So we did this before our break. How do you find what goes here with the p and the q? Negative 5 minus negative 3, which is what? No. negative 5 minus negative 3 plus plus negative 2, and then 2 minus 7. So it's going to be negative 2 and negative 5. That's the component form. Okay, now I want you to write it with i's and j's. I's and j's, switching from here is very easy. So u is equal to negative 2i minus 5j. Done. That's all you got to do. That's the ij form, the linear combination form. Now letter B says create a new vector w that is 2 times u minus 3 times v. So we treat it just like algebra. So w will be 2 times u that we just created, negative 2i minus 5j, minus 3 times v, which is up here, 3i minus 2j. So it said 2 times u, we just created u, minus 3 times v, and v is up here. Okay, now distribute and combine like terms. That's all you got to do. So w will be negative 4i, negative 10j, excuse me, negative 9i plus 6j. So w ends up being negative 13i minus 4j. So now we're going to take it a step farther, because this is actually where we go even farther with this. So let's say that v is a unit vector, one unit long, such that theta is the angle from the origin to the point cosine theta sine theta. Now why are those the x and y? Because if you remember on the unit circle, x was the cosine and y was the sine, right? Okay, so its ordered pair is cosine sine. So v then would be cosine theta sine theta in component form, or it would be written this way. Now actually I prefer the I and j on the end, so we're going to rewrite this as cosine theta I plus sine theta j. You can put the cosine theta and sine theta in a parentheses to separate them. I's and j's usually come last as far as I'm concerned. I like them better this way. Okay? So now we could actually write vectors in terms of the angle that they make with the x-axis. And this is great in physics application problems. So if v is any other vector, what if it's not just 1 unit long? What if it's 5 units long? What if it's 6 units long? What we do is that we then multiply each of the components by the length of it. So this is really now magnitude of v cosine theta I plus magnitude of v sine theta j. Okay, now we're going to make a huge connection that you may not have seen before. As soon as you write this down, I want you to think back to Polar Day, 2 days ago. We made a connection between x and y with r's and thetas. Who remembers what x was in terms of r and theta?
R cosine theta.
R cosine theta, write that down. Okay, and what was y? R sine theta. Now look how similar these are to these components right here. They both have cosine theta and sine theta, and they happen to be the x component and the y component. Okay? Now here's the interesting thing. How do we find magnitude? We did that at the beginning of class. We take the square root of the x squared plus the y squared. Okay? How do we find the length of r? The same way. The square root of x squared plus y squared. So when I'm doing these problems, that's the way my brain works. I don't think, oh, here's a whole new way I got to learn. No, I think of everything in terms of r's and thetas. So I'm going to call in this next one, they're going to give us a magnitude and an angle. I'm going to call the magnitude r and the angle theta. And we're going to write it in component form. Okay? So it's going to be r cosine theta I, r sine theta j. Okay? Now, before we go, well, actually we won't need to yet. We'll do that in a minute. So the vector is going to be v equals, so for x, we write 6 cosine theta I. Oops, oh, why did I write theta? What am I supposed to write? 60. Very good. Let's fix that. 6 cosine 60 degrees I plus, what would the second part be? 6 sine 60 degrees J. R cosine theta, R sine theta. Now, this paper is the only one in this whole course that is in degrees. And when we get to stuff we have to do in the calculator, which will be in a minute, we're going to have to change our calculators to degree form just to do this problem. But 60 degrees is 1 off the unit circle. What is the cosine of 60? Okay, 60 is pi over 3. So the cosine of pi over 3 is 1/2. So 6 times 1/2 I plus 6 times square root of 3 over 2 J. Okay, they want my answer in component form. That means without the i's and j's in the bird beaks. So V equals, what's 6 times 1/2? 3. And 6 times the square root of 3 over 2, reduce it?
3 square root of 3.
3 square root of 3. And that's my answer. That's component form. If I have a vector that is 6 units long at a 60-degree angle up, that's where the arrow would be. That's what it's telling me. Yes?
I'm sorry, what happens to the I and the J again?
When you put it in component form, you don't need it. Okay? Now, I did skip over the I and J thing I wanted to tell you. Let me go back and do that. Okay, what exactly does the I and J thing mean? Let's talk about that for a minute. Now, we came up here and we had this. Now, can you tell me, please, what this is in component form? What would that one be in component form? -2, -5. Now, remember that that means where the arrow is, if the tail is at 0, 0. So let me draw that real quickly. That happens to be in quadrant 3. So -2, -5 is where the arrow is, and it goes up to there. Are you with me? Now remember that I is a tiny little vector, 1 unit long, going to the right. Okay? So -2i means it's now going to be flipped over, because it's negative, and I'm going to have 2 of them going to the left. So -2i is like 2 little vectors going to the left. And then the -5j, the j vector usually goes up, but because it's negative, it's going to go down. And so we go down 5 little bitty baby unit vectors, and look where I end up. At the end of my vector that I'm talking about. So if you add up all the little vectors this way and all the little vectors down, you get the one that I'm writing as -2, -5. That's what it means. That's what the i's and j's are for. How many little vectors this way? How many little vectors up or down? That's what it means. Okay? All right. So you do this one. Do letter B real quickly. Write out the r cosine theta, r sine theta thing, and then put it into component form for me. So go back and look at it again. I kind of took a little detour, but you can do it. All right. Now let's apply this. We're going to talk about force. So we have 2 tugboats that are pulling a disabled cruise ship due east. One pulls with a force of 40 tons at an angle of 12 degrees to the northeast. That's going this way. And the other at 50 tons at an angle of 18 degrees to the southeast. So it's 18 degrees that way. What is the resultant force of the ship? And what angle does it travel? Okay, so these force values are our magnitudes, how long our vectors are. Okay, so what we're going to do is we're going to create i's and j's for both of these based on their force, their magnitude, and their angle. So we're going to say that ship number 1, okay, the first one has a force of 40 tons, and the angle theta is 12 degrees. Okay, and the second one has a force of 50 tons, and its angle theta is, it's not 18 degrees because it's not going in the same direction. If it says 18 degrees to the southeast, what do you notice about this angle? If you were talking about the unit circle, it would be negative. So when I write it, I have to write it as a negative angle. It is negative 18 degrees. Does that make sense to everybody? Especially by looking at the picture. Okay? So I want to find V1 plus V2. So we're going to call this one V1, this one V2. So we're going to write one big long math sentence with both of them in the I's and J's cosine and sine form. So this is like our R, and this is our theta. So we're going to write, this is going to be 40 cosine 12 degrees I plus 40 sine 12 degrees J. That's the first boat. What would the second boat be? 50, what? Cosine? Negative 18 degrees I, don't forget your I's and J's, plus, and it's always plus, angle doesn't matter, 50 sine negative 18 degrees J. Are you with me? Okay. These angles are not on the unit circle, so we're going to need a calculator for this. So please grab your calculator. The first thing I want you to do, everybody needs to do this or you're going to get the wrong answer. Push the mode key and change it to degrees. Third line down, it should be. Doesn't matter which calculator you have. Change it to degrees. Then go to the home screen. We're going to type in the two terms with I first. So we're going to type in this I term and this I term. So it's going to be 40 cosine 12 without the I. We don't type the I's and J's in. Plus 50 cosine of negative 18. Close your parentheses after the 12 and the 18, or you will get the wrong answer. 86.679 I. And then we do the same thing with the sine. Now let me show you a neat little trick so you don't have to type everything again. Go back up and capture the original problem. The only thing that's different is where every cosine is, there's supposed to be a sine now, right? So all we have to do is back up and on top of the cosine, type a sine and it changes it. Back up to the second cosine, change it to a sine, done. And there's my answer. Minus 7.134 J. This is V1 plus V2. So, can you tell me just by looking at that, if I was to physically draw and add those vectors together, which quadrant would it be in?
Third? No,
It'd be in the
fourth.
first.
It would be fourth.
Why fourth quadrant?
Because the Y is negative.
Because Y is negative and X is positive. That's quadrant 4. Very good. Okay, but this is not what the question asked. The question asked, what's the magnitude, what's the force, and what's the angle? Okay, so this is X, this is Y. We want to find R and theta. So let's think polars again. How do you find the magnitude? You can think of it in terms of polars, or you can think of it in terms of what we talked about earlier today. How do you find the magnitude? Square root of the x squared plus the y squared. So 86.679 squared. I was about to write I. No, I don't want an I. Plus negative 7.134 squared, which needs to be in a parentheses. So now we type that in, and I get 86.972. Okay, what should the label be on this number? Well, what were the other magnitudes? The lengths of the vectors, 40 and 50, what are they measured in? Tons. So this is tons. So those two tugboats together are in total exerting 86.9, almost 87 tons of force. Okay? Now we need to find the angle, theta. Now this paper hasn't really talked about it yet, but we did it on the polar day. How did we find theta if we knew y and x?
We solved.
Oh, y over x, the inverse tangent.
Inverse tangent. That was the formula, tangent inverse of y over x. That was the formula that we talked about. So in this case, it'd be tangent inverse of negative 7.134 over 86.679. And this right here is why your calculator must be in degrees. You will get the wrong answer if it's not. There we go. So we're going to do second tangent, negative 7.134 divided by 86.679. We get negative 4.705. Now, because it's a theta, what should its label be? Degrees. All right. So let's write a sentence saying what we solved. What were we looking for? The resultant force on the ship. That was the 86 number. So the resultant force is 86.972 tons. And then it says at what angle? At an angle of, now, there wasn't a single negative angle in my problem. It described the negative angle differently.
Oh.
How did they describe the negative angle? What does it say?
Southeast.
Southeast. So we're going to use that. We're going to say this is at an angle of 4.705 degrees to the southeast. So they can't pull the boat exactly straight, but it's off by just 4 degrees, almost 5. Is this coming back to you? Hopefully second time around making a little more sense. For me, since I've never had physics before, this is making a lot more sense to me now that I've seen it, I think, 6 or 7 times. Okay, can we turn the page? All right, turn the page, please. There's another problem like it at the top, but it's slightly different, so we've got to do it. First period I said, you guys can do it. Then I went, oh, wait, no, you can't, because there's something different here. Now, they were nice enough to give you a picture. Sometimes they won't, and you're going to have to figure out what it's talking about. First of all, we've got a plane traveling 500 miles an hour. Now, notice that the vector is labeled 500. That's its magnitude. In the direction of 40 degrees. Now, look where they put the 40. It's up here. That's not how we measure angles. Okay, why is it being measured like that?
Oh, is it a 90-degree angle? So can you subtract from the 40?
Yes, but why did they measure it up at the top in the first place? That's what I want to know. What do you think? It goes by the bearing. This is all bearing stuff, okay? Bearing is measured from north. So instead of measuring off of the horizontal axis like we're used to and going that way, bearing is measured off of vertical and it goes to the right. So this direction is positive. Okay, so this is really not theta. I'm going to call this theta star because it's a bearing angle. I cannot use that angle as it is in my problem. So theta star equals bearing. Okay, it is an angle, but it's not the one I want. I'm going to have to convert it. This is my R. That's my magnitude. So this plane encounters a wind going 80 miles an hour. That's a strong wind. In the direction of 120 degrees. That's another theta star because it's a direction angle. The question says, what is its resultant speed? That's its magnitude and its direction. So I need the angle again. So it's kind of like the same one, but I have to adjust it as I go. Now notice how the wind is going. The wind is down here and this angle right here is 30. So the plane has an R of 500, but what is the theta angle I'm going to use? Now Jocelyn was alluding to that just a minute ago. So if the angle at the top is 40, the theta angle I use has to be this one. So how big is that angle? That is 50 degrees. So my theta angle is 50 degrees for this problem. Okay. Now, the wind, they told me the rate of the wind is 80, and they told me the angle was 120. I don't see a 120 anywhere on there. How in the heck did they get 120? How did they get that picture if they said 120?
Is because like it's 40 degrees there, it's 30 degrees on the other side, so then they multiply them together.
Not
Oh, is it
all the
because,
angles on.
Okay, here's straight up. How far would it be to go 120 degrees? To here would be 90, and you would have to go how much farther? 30 more degrees. That's where they got that. Do you see it? Okay. So the angle I want is just off of horizontal. So how would I label that? 30 degrees? Not 30 degrees. Negative 30. It has to be negative 30. So this one is negative 30 degrees. To me, this is not one that makes a whole lot of sense of converting bearing until you just draw it. Just put it on paper and count it. It makes so much more sense that way. Okay? So now we're ready to do what we did on the previous problem. So we're going to have u plus v, or we could say p plus w if you wanted to, equals. So we write, what's the first one we write? 500 what? Cosine of 50 degrees I, don't forget your I, plus 500 sine 50 degrees J. Here's my plane. And we're going to add to that the wind. So that would be 80 cosine negative 30 degrees I plus 80 sine negative 30 degrees J. Let's type in the calculator. Do the two I terms first. Can y'all see that? U plus V equals 390.676 I. Now go change the two terms. Change the cosine to a sine, and we get 343.022 J. So now we need the resultant speed, which will be the magnitude of this. So this is the square root of the 390.676 squared, then the 343.022 squared. Remember, we drop the i's and j's when we do this. Yes? So we get 519.896. How should I label this? Miles per hour. Very good. Okay, so that's its resultant speed. So this, the wind actually speeds him up. He was only going 500 miles an hour. Now he's going 520. And so the angle theta is the tangent inverse of the 343.022 over 390.676. And I get 41.284 degrees. So we need to answer the question now that we found all the information. So what is that 519 again in terms of this problem?
Miles per hour.
Yes. It's his resultant speed. So it says find the resultant speed. So the resultant speed is 519.896 miles per hour. And the direction is, remember the direction is theta star. I just found theta.
So subtract that from 90.
Yes. So this angle is about right here. So the plane, the wind blows him off course just a little bit. So 41 is from the bottom up. So I need to subtract it from 90 to get what the angle would be this way. I need this angle right here. That's what I don't know. So it's going to be 90 minus my previous answer, which is 48.716 degrees. A couple more things we need to review. Look at the next part. It says dot product. Now, when you do a dot product of two vectors, you end up with a number answer. You don't end up with another vector. Dot product looks like multiply, and it sounds like multiply. But when you multiply these two vectors in this special way, you multiply the x's, you multiply the y's, and you add the two answers together. Okay? So, If you were going to do u dot v, that would be negative 2 times 3 plus negative 2 times 9. Add them together. So it's negative 6 plus negative 18 is negative 24. That's it. Now what do you think u squared would be? Let's jump to letter C. That would be u dot u dot itself. Negative 2 dot negative 2, negative 2. So what would that be? Yep, it's 8. 4 plus 4 is 8. Questions on that one? So that's dot product, okay? Now, the last thing we're going to talk about is one more vocabulary word, and that vocabulary word is orthogonal. My grad school class uses the word orthogonal all the time. And then every time I hear it and then I forget what it means, I go look it up and it says perpendicular. I said, why don't they just say perpendicular? Why? I mean, why do we have to introduce a new word? That's because it depends on what you're referring to. It tells you right here. Lines are perpendicular. Curves are normal. We talked about normal lines before. It's perpendicular to a tangent line. Okay? Curves are normal. Vectors are orthogonal. So it's a word that specifically describes vectors. Okay? So it just means that they're perpendicular. Now the one thing you need to know is that their dot product is 0. So if you're ever asked, are these two vectors orthogonal? Take their dot product. If you get 0, then they're orthogonal, then they're perpendicular to each other, okay? And the last thing you need to know is this. If you need to find the angle between two vectors, this is how you do it. This is where the dot product comes in. It's the cosine of the angle is u dot v over the magnitude of u times the magnitude of v. So let's do one of these down here. Let's do letter A. I want to find the angle between vector u and vector v. So here's what we do. We write cosine theta equals fraction bar. Please do u dot v for me. You don't have to get the final answer. Just tell me, what am I adding together? What two numbers with u and v if I'm doing the dot product? 3 times 4 is 12.
And 3 times negative 1.
Is negative 3. So that's all I want on top for now. And then I want the magnitude of u. Now we can do this in our heads. Remember, magnitude is the square root of x squared plus y squared.
With a square root of 10.
Square root of 10 times 4 and 3
Square root of 25.
is the square root of 25. Now I'll make it 5 in a minute. Okay? So 12 plus negative 3 is 9 over square root of 25 is 5, so this is 5 square roots of 10. That is the cosine of the angle. So how do I find the angle? Inverse cosine. So theta is going to be cosine inverse of 9 over 5 square roots of 10. And that's what I type in the calculator. So second cosine fraction bar 9 over 5 square roots of 10. And I get a 55-degree angle. So 55.305 degrees. Did y'all follow that? Do you remember learning this last year?
Yes.
Okay. Any last minute questions? Okay, we are done for today.